Hello friends, welcome to my YouTube channel. So today the problem that we are going to discuss is that is design a snake game. Okay, so let's go through the problem first. So it's like design a snake game that is played on a device with a screen size of height into width. Okay, now play the game online if you are not familiar with the game. It's a pretty old game that maybe some of you have already played on Nokia 3315, right? So similar game is this. So the snake is initial position at top left corner 00 with the length of 1 unit. You are given an array food where food I is equal to ri, I mean row I and column I is the row and column position of the piece of the food that the snake can eat. And now when the snake eats that piece of food, its length and the game score will be increased by 1. Okay. Each piece of food appears one by one on the screen. So there's a food array that is given. So first of all, the food at index 0 will appear on the screen. Then food at index 1 will appear on the screen, so on and so forth. Okay. So meaning the second piece of food will not appear until the snake eats the first piece of food. So when the piece of food appears on the screen, it is guaranteed that it will not appear on the block occupied by the snake. So it will not appear on snake's body. The game is over if the snake goes out of bound, hits a wall, or if its head occupies a space that its body occupies after moving. Okay. Snake of length 4 cannot run. That is, a snake of length 4 cannot run into itself. Yeah, I mean, he cannot kind of bite his own body. So, yeah. Implement the snake game class. So, it is taking kind of three parameters. One is the width, height, and the food array. Okay. Initializes the object with the screen of size this and the position of the food. Now, there are two methods. I mean, one is the constructor, another is the move method, right? So, move method is basically accepting a direction, which is kind of also returning the score of the game after applying one direction move by the snake. If the game is over, then you need to return -1. So game is over in case of two um, scenarios. One is if the snake touches the boundaries, or I mean he bites his own body. Okay, so these are the two scenarios in which we need to return -1, right? And another is, I mean, once he eats the piece of food, his length increases by 1, and that's how, I mean, the score of the game as well. So, yeah, now let me explain you the problem after like drawing on the diagram. Let's just a minute. Yeah, so think of this kind of as a height into width kind of, wherein I mean you have 5 rows, which is the height, and you have 5 rows, which is the height, and you have 6 columns, which is the kind of width, right? So this is kind of height into width, right? So height as 5 cross 6. But now let's take it that way. Now let's assume you have some snake already there, right? So for example, let me draw a snake. For example, this is the snake, right? For now. Okay. Now, if you want to, okay, let's see. For now, this is the snake. Okay, kind of this is the body of the snake. So body of the snake is on multiple, like this is kind of a position 1 2, right? 1 1. Okay, this is the position, say 1 2, right? This is the position, say, okay, this is the position, say a kind of 1 3, right? This is the position, say 2 3, correct? So the snake body is on these four positions. Okay, now I'll say this is the head of the snake and this is the tail of the snake, right? So he moves in this, I mean, this is the part that is the head of the snake, and this is the tail of the snake. Let me write it down here. So this is kind of a head. Let me just, so this is a head, okay, and this is a tail, okay. This is the tail. I hope that is clear in the diagram. Now when I press down, okay, there are four directions that are there, kind of up, right, left, down, okay. These are the four direction in which this snake can move, okay. For example, if I press down, right, so the head of the snake will come down, right. So if you see, the head will come here, now head will come here, okay. Now this will be kind of the body, and the tail will be removed from here, kind of tail will come here, right. It's the tail, this is the new tail. So if I draw it, just remove it, this is the new tail, correct. Now again, this is, sorry, let me move it. Now you have already clear about the, I will not use HNT, but just give you an idea. So now the snake is at these four positions, right. Now again, if somebody presses down, so head comes here, and now this will be moved, right, this will be moved. Similarly, if another person presses down again, so this will be here, and this will be kind of moved, correct. Every time it has kind of a four, so it has four parts, kind of, right. At each cell it has one part, so the size of the snake is 4, okay. Now if now you press left, now if you press down again, for example, so the snake will kind of cross its boundary, and it will die, kind of, and the score will be -1. You need to return -1 in that case, okay. If you are now in your move method, if this is the current state of the snake, and somebody passes down in your move method, okay, so the snake will die, right, because this is the current state. So it will kind of, its head will be hit with the boundary, okay, and it'll die, and you will return kind of -1 from the move method, okay. Now if somebody presses, say, left, okay, if somebody presses left, so how it will move, it'll, the head will come here, and yeah, it will be removed from here. That's how it is moving, right. So basically every time you will add something to the head, so every time it moves, you add something to the head and you will remove the tail, right. Every time you add something to the head and you remove from the tail, okay. This is what you are observing, right. So what kind of structures give you that? If you need to kind of keep track of the body cells of the snake, so these are the four body cells, right, of the snake, correct. If you need to keep track of them, so every time one cell will be increasing on the head, and I mean tail will be removed, head will be kind of added with one cell, and tail will be removed, right. So I mean that is kind of a linked list kind of a structure, it's linked list kind of a structure, but I mean since it is updated from both the sides, so we can take kind of a DQ, right, doubly ended queue, right, because we are kind of adding it in the starting, and we are removing it from the end, correct. But now see, if food comes in between, right, for now, let's say if you encounter, so this is the food, okay. If now if somebody presses left, so what will happen if somebody presses left, right, so the head will be moved here, so just a minute, the head will move here, okay, but the tail will not delete, tail will not be removed in this case, because we need to increase the length of the snake. So if we kind of add something to the head and we also remove tail, so the size will remain same, right, but we need to increase the size of the snake in case he eats food. So in that case, when he eats food, that means head will be kind of, we'll add one body cell, we will not remove the tail one, so tail one will be there as it is. So that's how, I mean, it's now the size will be 1 2 3 4 5, right? Now the size will be 5. Hence, I mean, its length got increased and the score also got increased, right? So in the starting, I mean, when the length is 1, okay, the score is 0, right? So the score will always be the number of body cells minus 1, okay? So that you should remember, right? Another thing, okay, now this is the one thing. So now you know, right, when the head of the snake hits the boundary, for example, now the snake moves again, now on the left, then again if somebody presses left, so it will hit here, right, this wall, so he'll die. So this is one of the conditions wherein a snake can die. Another condition could be, let's take another example, okay, let's take another example. For example, your snake is, this is the position of the snake, right? This is the position of the snake. This is a tail, this is the tail, and this is the head for now, okay? Now when somebody presses now left, for example, somebody presses left, so it has to move left, right? It has to move left. When he moves left, so what do you think, will it kind of bite his own body or not? He will not, right, in this case, because this is the tail. So tail will also move ahead, right? As soon as he moves here, the head moves here, tail will move also the up, right? So if now see, now if he moves from this position to this position, correct, this will become head, right? This will become head and this will become tail, correct? So it will not die, correct? So you need to take care of this scenario wherein if he bites or he touches with his own body, okay, while moving, so you need to make sure if he touches the tail, his own tail, then he will not die, because tail will move again like ahead as well. So but if he touches any of other body parts rather other than tail, then I mean he will die, okay? For example, the tail would be here, right? If this is the tail, let me draw it again, okay? Okay, so if this is the tail and this is the head, okay, now if somebody presses left, okay, now if somebody presses left, so it will collide, right, with its own body. Say it's, it will collide with this, right, because tail will move ahead and it'll collide with tail, kind of. So I mean, that's how he will die, okay? But if you have kind of head here and somebody presses left now, so he will not collide because tail will also move ahead, right? So yeah, so this is the edge case that you need to keep in mind, that when you are tracking the positions of the cells of the snake, now if snake is touching the positions, I mean, he will die in case of a move. But if he's touching the tail, then he will not. Okay. So this is one thing. So now if you see, right, if you need to track kind of, so you need to track the body cells of this snake, that can be tracked through DQ. I already given you an example, right? That okay, we are kind of adding data in the head, or maybe in the starting we are adding data and we are removing from here. So that's how, I mean, DQ will be a perfect fit. Another thing is you need to track kind of the all the cells of the snake, right? I mean, which all cells are being occupied by the snake. So to track that, you can use a set, right? Set, and in that you can, like, you can add kind of a positions. You can have a custom object, say position, which is having kind of x and y coordinate, okay, and you can keep a set of those positions. That's how you will be able to track that okay, these are the positions which are being occupied by this snake. Now as soon as kind of you remove, like, or maybe add a position into DQ, you will also add it into the set. As soon as you remove it from DQ, you will also remove it from the set, so that it will be set and Q will be kind of a consistent, right? So I mean I hope you are like clear about this thing. So set, you are keeping track of the what all positions are being occupied by the, in DQ also you will have, but in set you have this um, maybe you have the lesser complexity. So in order of one you can only check that, okay, whether this cell is occupied by this snake. So you need to check, right, when snake moves, so whether the next move that is moving, for example, this is the snake, this is the head, okay. Now if he moves left, so you need to check whether this cell to which he is moving is occupied by his own body or not. If yes, then you need to return -1, right? Then he'll cut his own body. So yeah, and to track that, you can keep all the position in a set, so that now if you want to check that, okay, you will give this position, right, that will this position be occupied, so this set will say yes, it is occupied, since it is already there on the body. But you need to kind of tail will be an exception, right? That should not be a tail, because in case of tail will, is also moving ahead. So you can add that condition when you are checking that. Okay, another thing is, so DQ is one thing wherein you are maintaining the body of the snake. Another is set, wherein you are tracking the, okay, these are the positions that are being occupied by the body of the snake. Another thing could be, so I think these two things, and two boundary conditions. One is kind of basically the matrix boundary. You need to check that whether snake should not hit that boundary. Another thing is this the tail part that I've already mentioned. Okay, now let's try writing this, how we will write this solution. Okay, so let's first of all copy this part, that is, yeah. Okay, now see, you have the width and height. Okay. Now first of all, there are some structures you will take, right? This is kind of to track the snake body. Okay, in that sequence only that structure will be, so it will be Q kind of, it will be DQ. Okay, before that you will, before DQ itself, you can define a position class as well. So okay, it will have kind of a X and Y coordinates. Okay, now it will have a constructor, say also generate the uh, where is that, yeah, generate equals and hash code. Yeah, for now we'll talk about that, how you can generate these hash code and equal function, how they are used in a separate uh, class. Maybe you can comment if you want to know how they are being used. So basically, since we are putting this position to a set, so that's why I've overridden these equals and hash code methods. Okay, so okay, now we'll say DQ. So DQ will be DQ of positions, right? So this will be kind of a snake body. Okay, now this is the snake body. Okay, and another is kind of, you will take a set, okay, to check whether this position is being occupied by snake or not. Okay, so you will have kind of a set of positions. First of all, set of position. So this will be kind of maybe again it is a snake body, but you can say this is snake and this is kind of body cells maybe. Okay, so the body cells. Okay, now these two things we have. Anything else I need to take care? Let me think. Okay, so let's go to the problem once. It is saying it is moving right down. So basically it's the top left corner, right? So let me just give me a second. So it's here, right? Snake is the size of the snake is 1 in the starting, and it starts from 0 0. Okay, now it can go left, right, up and down, right? So when you say up, so that means your x is, or maybe row and column, right? So this is say this is your, when you say up, so if you are placed here, you are going up, right? So you are decreasing the rows, so you are decreasing the rows and your column will remain same, right? Here you are kind of, if you are going down, you are increasing the x and your column will remain same. If you are going left, so sorry, I should rather say this is left and this is right, right? So if you go left, so if you go left, so your row will remain same and your column will be kind of decremented by 1. And now if you go right, your column will be increased by 1. Okay, so these are the 4 things you need to keep in mind. So with ULRD, so this is what 4 directions you mean. So let's make a direction array as well in the starting. Let's make a direction array that will be kind of, so these are the 4 directions, right? So first of all, if I say, okay, so up, down, right, left, if I say like that, okay, up, down, right, left, so up, down, right, left. Okay, what is up? -1 0, right? What is down? 1 0. What is right? 0 1. Left 0 -1. Okay, now you can also say this is up, down, right, left, right? Now you can also create a map kind of structure which will give you, so this is map, this will be kind of string comma integer, right? So this is dir map. Okay, this is kind of a direction map. You'll take care of the directions. Okay, now when you initialize it, maybe like this is another way of, rather than doing it here, you can initialize it here. So dq or maybe snake is equal to this, then this will be here, then body cells again, this will be here. Okay, now directions. Okay, okay, it's better to initialize it there as well for number for direction since. Okay, and this direction map you can have it here. Okay, and you can put in the direction map, right? Since it is kind of at 0th index, it is up, right? So you can say dot put up is kind of 0th index, right? Similarly, we can have these four directions. Okay, so for down we have one, we have at first index we have down, at second index we have right, at third index we have left, right? So yeah, these four direction map is being populated. Okay, now in the starting we have kind of snake dot add, so we'll add kind of a new position that is 0 0, right? It starts from 0 0, correct? So we'll add that position, and also we will add it to the maybe body cells. So snake body cells will be at new position 0 0. Okay, we can create the same object and we can pass it to both, but yeah, this is also doable. Okay, another is now this is the starting, right? And what else I can think of here? So we have initialized this direction map, and we added the 0 0 cell to the snake and the body cells. Okay, now anything else you can think of? Okay, see, let's move to the this method, direction method now. So now we'll check the direction, right? Okay, if maybe based on direction we can, from the direction map, based on direction we can get the index, right? So this direction will be either up, down, right, or left. Based on that we'll get the index, right? Now we are at a particular position right now. So from DQ, from maybe snake will give me kind of snake dot peak will give me the head of the snake, right? So this will give me the head of the snake. Okay, this will give me the head of the snake. Now I know that, okay, this is the current head. Now what is the next head position? Next head position will be uh, okay, let's think about the next head position. Okay, next head position will be current head dot x plus, so this is the direction map, right? If I from direction map I'll get the deltas, right? I'll get the deltas from the direction map. So this will give me an int array of dir change. So yeah, this will give me kind of a dir change, right? So with that dir change of 0, we'll get the next this, and current head dot y dir change of 1. This is next head x, this is next head y. Okay, and if you talk about the kind of next position to which it is moving, so this is the position to which it is moving now. Okay, this is the next position of this mhm. This is the next position to which it is moving now. We need to check first of all that if the next position is out of bound. Okay, so I mean, or maybe you can say, is it valid? So you should have kind of a is valid method. Let's say is valid method, which will take kind of the height and the width and the next x and next y. Okay, these four things it will take, and it will return kind of if height or maybe next x is less than equal to 0, greater than equal to 0, and next y is greater than equal to 0, and next x is less than height and next y is less than width. Okay, this is what the return type of this. Okay, now we'll check first of all if is valid next height. Okay, let's take these two variables also. So let's make say int height, int width. So this dot height equal to height and this dot width equal to width. So these two will be, I mean, we are able to use it here, right? Now we'll have kind of a height, width, and next x, next, next, next y. Okay, if this is valid, if this is not valid, for example, if it's not valid, return -1, right? We need to return -1, correct, in that case. Okay, now we know that if the next move is valid. Okay, now we need to check whether the snake bites his own body. Okay, now first of all, for this we need to see that the position to which the snake is moving, that position should not be there in that. So we'll say set dot, or maybe snake cells body cells dot add. Let's try adding this, or maybe if that contains, okay, contains new position. What is the new position that we should check for? So new head x, new head y, right? This is the new position I'm checking. If it is there in the body cells, then we should say it is biting his own body, right? I mean, since it is already capturing the body cells of the snake, and if the next position to which the snake is moving, that position is already there in this body cell, that means it is already biting his own body. But one more condition we need to check, that it shouldn't be the tail. Okay, so we should say on snake dot get last. Okay, so this is kind of a tail, right? Tail position. This is the tail of the snake. So next head is equal tail dot x, and next y is equal tail dot y. That proves that it is touching the tail, right? I mean, that is the tail, but you should say if it is not touching the tail, and if that is there, then return -1. Okay, this is second condition. Okay, if, I mean, it is touching his body, but it is not tail, okay, then we'll return -1. Now, we'll, okay. Third thing, we are getting the food array. Okay, let's take the food array as well here. Okay, let's say food, this dot food is equal to food. Okay, we'll get this food array as well. Let's take another, say, food index. Okay, in the starting it will be 0, and say if my food index is less than food dot length, then I'll need to check that now. I'll get the food dot, or maybe food or food index. Okay, this will give me kind of current food. Okay, now I know that I'm at next head, next y. I should check now if my next x is equal current food dot x, oh sorry, current food 0. Okay, so that is x, and so I'm just checking if the next position to which I'm moving, if there is any food that is there. Okay, the food is there. Okay, I'll eat that food, right? So my food index will be plus. Okay, I'll eat that food. Now I also need to kind of I also need to remove the, okay, I also need to remove, say, snake dot pole last. Correct, I need to remove kind of the last element from the snake, and I'll also remove it from the cell's body, right? Body cells, because snake is moving ahead, right? I should remove the tail every time. So this pole last will be kind of a tail. I'll kind of remove the tail. As soon as I remove the tail, I'll also kind of mark that body cell as empty, right? I'll remove it from the body cell. So I'll say remove, and yeah, the position which I'll say remove this. Okay, remove the tail. This will do the job for me. Now, do I need to remove the tail in case I find the food? No, right? So if I have kind of a boolean food found, right, it's false. Now if I found the food, if I found the food, if I didn't find the food, then only I'll say this, right? Then only I will remove, otherwise I'll not. Then I should remove the tail. Otherwise I should keep on incrementing, like my the size of the snake will keep on incrementing if I found the food in the path. Okay, so I'll not delete the tail. Okay, now what is the size that I need to return? So that is kind of a snake size minus 1, right? Since in the starting the snake size is 1, score is 0, correct? That's how, I mean, I should return. Now, is there anything else? So food, if it's not found, so I'm removing it. And yeah, if it is, now if these two are not true, so I should add that new position to kind of the body cells as well as to the DQ, correct? So I haven't added that new position anywhere, right? So if I'll add that before returning the size, I should say body cells. So first of all, I'll, sorry, just bodies, or maybe snake dot add first. In the starting, you need to add this position. Okay, new next ray, next head X, next head Y. Similarly, I should say body cells dot add new position, right? Huh? That's how I think this should work. Let's try submitting it and see. Yeah, it is working. Yeah, thanks guys for watching, and please leave your comments so that we can like work on improvements in this channel. Thanks a lot.